Hi everyone. In today's lesson we're going to be talking about factoring trinomials. But before we can do that, I'd like to first recall multiplying binomials. So you see this problem and I ask you what do you need to do to solve it, and you're going to tell me double distribute. You would multiply x times x times 2, 15 times x, and then 15 times 2. So let's go ahead and do that now. So we're going to multiply x times x, and we're going to write it down here because we're going to need some space. X squared. Now we're going to multiply x times 2. That'll give me 2x. Then we're going to multiply 15 times x, and we'll give that 15x. And then we're going to multiply 15 times 2, and that will be 30. Now if we look at this expression here, we have two like terms. So my final answer will be x squared plus 17x plus 30. Now let's see if we can make some conclusions. Multiplying these two binomials together will always result in what? What type of expression is something like that has these three terms? You want to say trinomial. So no matter what, if you're going to take two binomials and multiply them together, you'll always get a trinomial. Now what I'd like to do is label these parts of these binomials. So this x and this x are in the first positions of these parentheses. So we're going to label the x, these two x's, with firsts. Okay? Then we multiplied x times 2. This x and 2, they're on the outsides of the whole thing. So we're going to say the x and 2 are called outers. Then we multiplied 15 and x. These are on the inside, so we're going to call these inners. And then we multiply the 15 and the 2. These are the last positions of each of these parentheses. So we're going to call those the lasts. Okay, so if you multiply, let's look at the conclusions now. If you multiply the first together, so x and x, you will always get what term of the trinomial? The first, the middle, or the last? So again, if you're going to multiply the first together, the x and the x, you will get the first term of the trinomial. Okay? If you multiply the lasts together, so the 15 and 2, those are my lasts, you're going to get your 30, or your last term of the trinomial. Okay? Now this is the tricky part. If you multiply the outers, so the x and the 2, which gives me 2x, and the inners, the 15 and x, and then add them together, 2x and 15x, you'll get the middle term. Okay? Now I know this can be a little confusing, but I want to apply this to factor the trinomials. Now, some of you may learn different methods to factoring these trinomials from other teachers, and we can definitely discuss those methods in class, but I want to go over this one first. So we're going to factor all four of these expressions using reverse double distribute, if you would. And like with all factoring, we want to check for a GCF first. So is there a number or a letter that I could divide all three of these pieces by? You should be telling me no. So now I kind of want to figure out what two binomials multiplied together to give me this trinomial. Well, we know to get the first term, we have to multiply the first two. So x times x is the only thing that's going to give me x squared. Okay? Now we're going to put the lasts together in here and here. And we're going to see if these lasts are going to help me add up to 17. So it helps if you plan it out. So here are all the factors of 30. 1 and 30, 2 and 15, 3 and 30, and 5 and 6. We want to figure out, so let's just assume that we want to pick 1 and 30. If I put 1 here and then 30 here, what's going to happen when I multiply the outers, these are the outers, and these are the inners, I get 30x and then 1x. Will 30x and 1x, when I add them together, will they give me 17x? No, so this one can't be it. So this one's out. So now let's erase everything that we did and start over. Okay, now let's try the 2 and the 15. So I'm going to put a 2 here and a 15 here. I'm going to multiply the inners, which gives me 2x, and the outers, which gives me 15x. So does 2x plus 15x add to my 17x? Absolutely does. And that was a positive 2 and a positive 15. So I'm done. Okay, let's move on to the next example. X squared minus 5x plus 6. So again, we're going to reverse double distribute. So what two things are going to multiply to give me this x squared? You should be saying x and x, so these are going to go in here. And now I want to find the factors of 6, that last term, so that when I multiply these two, I'll get that. Okay, let's write down all the factors of 6. So we've got 1 and 6, and 2 and 3. So I'm going to put a 1 here, just for fun, and a 6 here, and see what happens. I multiply the inners, I get 6x. I multiply the outers, I get 1x. Is 6x and 1x going to add to negative 5x? No. I mean, technically, you could also have a negative 6x and a negative 1, because a negative times a negative still multiplies to that positive. So technically, we could do a negative 6 and a negative 1, but that's going to only add to a negative 7, not a negative 5. So this, unfortunately, is not working. So we're going to have to skip this part and try the next pair. Okay, so the other pair was, we had 1 and 6, and we had 2 and 3. So let's try 2 and 3. So when I multiply the inners, I get 2x. When I multiply the outers, I get 3x. Now, 2x plus 3x is a positive 5x. How do I get it to be a negative? Well, I'll just put a negative here and a negative here. And let's see if it works. Does a negative 2 and a negative 3 add to a negative 5? Yes. And does, when I multiply the last, negative 2 times negative 3, multiply to 6? And the answer is yes. Okay, let's try example number 3. Same concept. We're going to put an x here and an x here. Now I want the factors of this 40 that are going to add to that negative 3. So I know it says negative 40, but let's just think about it. We'll put the factors of 40. So 1 and 40, 2 and 20, 4 and 10, 5 and 8, and that's pretty much it. So we want to figure out the factors on this list that are going to somehow add to this negative 3. Well, in order to multiply to a negative 40, one of them has to be positive and one of them has to be negative. So we can make this whole row down here negative if we want, and let's just see. So if I'm going to add negative 1 and 40, I'm going to get 39. That's not going to be this. Which pair do you think differs by 3? Just looking at them. This pair. Let's see if it works as is. Minus 5 plus 8. Well, it multiplies. Your last term is going to work out. Negative 5 and positive 8 will multiply to a negative 40. But let's check this inner term. So we're going to multiply the inners, negative 5x, and the outers, which is 8x. So when I add those, negative 5 plus 8, I'm going to get a positive 3, not a negative 3. So let's just switch the signs then. Let's make this a positive 5x and a negative 8. So positive 5 and negative 8. Let's see if that works. Positive 5 plus negative 8 is definitely a negative 3. And 5 times negative 8 is negative 40. That works just fine. Okay, let's try number 4. Number 4 is a little bit different because these numbers are pretty large, and you want to see that there's actually a GCF of a 2 that you should probably divide out first. So we're going to divide each piece by 2, and this is what we would get. And now we're going to factor this inside. So using a trinomial, we're going to factor it, and we're going to put x and x, bring down this 2 so we have it. So again, we now want to find the factors of a negative 100 that are going to add to negative 21. There are indeed a lot of factors of 100, so let's just write a few of them. We've got 1 and 100, 2 and 50, 4 and 25, 5 and 20, 10 and 10. That should do it. Which pair, just looking at the numbers, I know it says multiply to a negative 200, so we know one of them is going to have to be negative like this, but let's just analyze it. Which pair of numbers do you think is going to add or come up to a 21? Well, 10 and 10 is 20. This is 101, 52, 25, and then 29. That's if you add them. What happens if you subtract them? 100 minus 1 is 99. 50 minus 2 is 48. 25 minus 4 is 21. That might be it. 20 minus 5 is 15, and 10 minus 10 is 0. So it looks like this is your pair. Now one has to be positive and one has to be negative. So we know that it's 4 and 25. And we said, well, we have to add to a negative 21. So we need to make this a positive 4 and a negative 25. And then we're done. All right, let's move on to the next page. Okay, now these examples are factoring trinomials where the leading coefficient is greater than 1. Here's the leading coefficient. It's a 2, it's a 6, an 8, and a 4. So I'm going to try the first two with you. Now let's again, like all factorings, we're going to check for GCF. Is there a GCF between 2 and 27 and 3? No. So we're going to do the same thing. We're going to do that reverse factoring. So it's a little different. How do I multiply to get a 2x squared? We'd have to put a 2x and an x. And now in these back ends of the parentheses, or the last, we want them to multiply to 27. So let's write down the factors of 27 again. 1 and 27, and 3 and 9. That's pretty much it. And again, it has to multiply to a negative, so one's going to have to be positive and one will have to be negative. Let's play around and see if I use the 1 and 27. Inners, outers. 1x and 54x. Is there any way, when I play with them negative and positives, that I'm ever going to add that to negative 3? No way. So this one is out. Let's try. The 2x and x is going to stay. But now let's try this pair, 3 and 9. So I'm going to put the 3 here and the 9 here and see what happens. So inners is 9x, outers is 6x. Okay, how can I get a 9x and a 6x to add to a negative 3? Well, this has to be a negative 9 and this has to be a positive 6. So negative, positive. We're done. Okay, let's try example number 2. So we want to check for GCF. Is there a number I can divide all 3 of those by? You should be saying, yes, I can divide all 3 pieces by 2. So when I divide them, I get this. That's an 11. Okay, so now I'm going to set this up the same way I set these up. So how do I get 3x squared? I'm going to need a 3x and an x. Okay, bring down this 2. And now I want to find the factors of 4 that are going to add to negative 11 once I put them in here. So we're going to try some things out. Let's put a 4 here and a 1. 4 and 1 multiply to 4. So inners is 4x, outers is 3x. Is there any way that I'm going to add 4x and 3x to be negative 11? No. So that's totally out. Okay, let's try a different pair. How about we try the 4 here and the 1 here. So this is 1x, the inners. My outers is 12x. Is there a way that I can add these two together to get a negative 11? Well, yeah, I mean, this is going to have to be a negative 12, and this will have to be a positive 1. So we're going to put a positive 1 here and a negative there, and we're good to go. You always want to check, though, to make sure that the last terms, 1 and negative 4, multiply to negative 4, which it does. Okay, let's look at example number 3. Is there a GCF that I can divide all 3 pieces by? No. But what makes number 3 harder than all the rest is that technically you could have 8x and x to multiply to 8x squared, but you could also have, I'll write them down here, 4x times 2x. So there's going to be a lot of guess and tests here, but it's nice because the only thing I'm trying to multiply to is 5. So it's only going to be 1 and 5. So let's test it out. If I put a 1 here and a 5 here, this will be 1x and 40x. Way too big. No way that that's going to add to 22. So let's switch it. Let's put the 5 here and the 1 here. So 5 times 1 in here will be 5x, and then 8 times 1 will be 8x. So that's not big enough. We have 5x and 8x adding to 22. No, it adds to 13. So that one's totally out. So now let's try 4x and 2x. So I'll put the 1 here maybe and the 5 here. So the inners is 2x, the outers is 20x. When I add them, do I get 22? The answer is yes. Okay, how? Plus and plus, add them up. That's it. Why don't you see if you can do number 4 on your own? Pause the video until you've finished it, and then I'll go over an explanation of it. Okay, so what I did was 4x and x, and then I tested all of the factors of 35. The first thing that came to my mind was 5 and 7, just because I've been memorizing my multiplication facts. So I'm going to try and put the 7 here and the 5 here and see what happens. 7 times x is 7x. 4 times 5x, 4x times 5 is 20x. If I add these, I'm going to get 24. There's no way I'll get that, so that's not going to work. So let's try, same problem, but switch the 5 and the 7. So 5x is the inners. The outers are 28. Do we think this will work? 28 and 5? No, this doesn't seem to be working at all. There is another option, though, about 4x squared. Couldn't we do 2x and 2x? So let's start over with that. Okay, so 2x and 2x may work. And let's put the 5 and the 7 in anywhere. See what happens. So inners is 10x, outers is 14x. Okay, that worked beautifully because 10x plus 14x is 24x. So 2 plus signs and we're done.